All right, this one's going to be very different, kind of. But let's read it first. One inlet pipe can fill an empty pool in 6 hours, and a drain can empty the pool in 9 hours. How long will it take the pipe to fill the pool if the drain is left open? So this one, notice there's no miles per hour, there's no distances, there's time, we got the hours, but we can't tell like a rate on this. The only thing they say here is that it can fill an empty pool in 6 hours, and then it's empty in 9 hours if you drain it. So I don't see anything in terms of distance on this. Again, you could say you got a rate, hours per pool or something like that. But the reason I'm bringing that up is that this is a job application type problem, okay? A job problem, okay? So again, I'm looking for jobs as a ratio to hours on this one. And we got two parts to this, right? You can either fill the pool or you can either empty the pool. Okay, so before when we looked at these job type problems, it was just like you and a pal. But now we're looking at a pool that can be either filled or be emptied. So in filling and emptying the pool, the other thing we'll need to notice on this one that it's saying how long will it take the pipe to fill the pool, but while the drain is open. So that means we're looking at filling while also being emptied. So that means we're looking at both of those, okay? So if I take the filling and the emptying together, so that means I'm going to put them together. So I'm going to show addition right here, even though in the future we know emptying means it's being taken out. And so if you wanted to, you could, if you wanted to, just make that a minus. Okay, so in fact, you know what, I will stick with that, although what I was going to do is make that plus a negative, which in the end would have just made it minus, okay? So I'm gonna take away the emptying because it's being subtracted there. Now, these fractions are gonna be shown in jobs per hours. And so I know filling this up, I can fill one pool, and it's a ratio, one pool in, up here it says you can fill it in 6 hours. But then you can empty it, it says in 9 hours, so emptying the pool, again, you can do one pool, empty it completely in 9 hours. And again, this, if you take the filling and then subtract the emptying, then you get both. So you should, with both, you should empty a pool, but we just don't know how many hours that's going to take. So up here, I'm going to use X. You could use P maybe for pool, but I'm going to use X. So X that's going to take, that's how long it will take to fill the pool while the drain is open, okay? Which of course is not very efficient, but now I know X, it says how long, that's hours. Okay, now that I've got that, I'm ready to reset this up just without the labels. So on this one, again, we are subtracting because we're emptying the pool because it's being taken out, right? We're taking the water out. But now that I got this, I need common denominator. So again, I've got the X denominator here. These ones don't have X's. It's a pretty quick thing that I can just apply there. So 9 times X, but just make sure you multiply it by the numerator and denominator. And then the 6 as well. I got to multiply that by X. And so the numerator by X. So I've got X's to match. Now I just need the numbers to match. 6 and 9, they're not multiples of each other, but I can find a common multiple of 18 with these. And so that's what I'm going to do. I'm going to take these, I'm going to make it an 18 denominator. So of course the X I could just multiply by 18, and so the 1 by 18 as well. The 9 I'd have to multiply by 2, and so the 1 by 2 as well. And again, the purpose of the 2 times 9 is to make that 18. The 6 though, I'm going to have to multiply that by 3. Okay, so what do I get out of this? Well, I now have, from the first fraction, 3 times 1 times x would be 3x's, all over 3 times 6x would be 18x's. Okay, and then from the second fraction, 2 times 1 times x would be 2x's, and then 2 times 9 times x would be 18x's. Again, the whole purpose of that last part of this exercise was to get the denominators to match. And now in the final fraction there, 18 times 1 is 18. 18 times x is 18x. So now that my denominators match, I can now rewrite this, but without any of the denominators. So that means I now have 3x minus 2x equals 18. And yeah, I right now have two like terms that I can combine. 3x's minus 2x's gives me 1x, which means that we have, in fact, already solved for x. Okay, so I'll just make that a phantom 1. But what did x represent? We set up here, it's how long it will take to fill the pool while also draining it. So it looks like it will take 18 hours to drain the pool, and I'll specify that with a sentence here, just because hopefully that makes it nice. Okay, so hopefully that kind of makes sense right there. Now, would you have to write this on a test? Of course not. We just expect this, and of course the work. But however you say it, if you want to take the shortcut and just say 18 hours is good, but if you want to write it like that, that's fine too.